subroutines and interrupts. So these are some of the objectives we're going to look at. That's how to name subroutines, unconditional, conditional, input devices, look at this. We'll learn the difference between interrupts and subroutines. So, what we're going to do, additional ladder programs or routines within a project or main program is called a subroutine. Okay. An unconditional subroutine has no input instructions. A conditional subroutine would have input instructions between the subroutine. The jump subroutine is an output. Structured programming, I learned this real fast when I first got into programming. Of course, the first programming language I ever used was machine language. It was a binary language for a Motorola 6800 processor. And then we moved into BASIC. I don't know if you're BASIC, all-purpose instruction code for computers. It was a text-based programming language. And then we'd write these big old long programs. And then when it came time to edit it, if we had a problem, it was almost impossible to find what was going on. So a subroutine consists of several modules or subroutines that is not as lengthy as a module. Subroutine advantage, we can test individual sections of a program to verify that it's working okay. It makes it so much easier to troubleshoot and maintain. It can be called from the main program or another subroutine. So basically, this is what we do is we're going to take, if we got a really long program. So we hadn't had the opportunity here because all our programs are what? Short. But if we look at the programs that runs the Festo line over there, if we look at the programs that run the Amatro line, if we look at the programs that's running that robot, it would probably be, good gracious, it'd probably be 200 or 300 lines of code. And I want to figure out, I'm having problems with a point out there when it picks up a cylinder, and I've got to find it inside that 100 lines of code, right, you understand? So what we do is we break it up into individual little modules. Usually each module has its own dedicated function, and it makes it real hard to do. So we can test programs, we can troubleshoot, we can maintain. So this is called structured programming. Is when you take a long program and split it up into individual modules, what we refer to as subroutine. So we call subroutine 1, subroutine, we call it calling. So when a program asks for it to run a subroutine, it says that we're going to call that subroutine. That's the term that we use. So we have a subroutine instruction. It's called JSR, jump subroutine. We put it inside the program. We go out, we write our individual routine the way we want it, and then we would come in, and when we run it, we just call the subroutine. It goes out there, runs the subroutine, scans through it one time, and it comes back to the main program. We can also have subroutines call subroutines. This is called nested subroutines. So RSLogic, our designer, RSLogic 500 allows 25 nested subroutines. With parameters that we can pass, and we'll look at that just a little bit. Normally we put an SBR instruction to identify it as a subroutine, and then the return instruction tells it to come back to the original program. Of course, they've made it a lot easier. So we can have subroutines called the subroutines. And then we can have that subroutine called a subroutine. And it always remembers its what? It always remembers its path back. So here's our instruction. This is JSR, jump subroutine. Jump to a subroutine instruction invokes another routine. And the routine completes, the execution returns to the JSR instruction and then continues on from there. The optional SBR instruction receives input parameters passed by the JSR. The optional return instruction passes parameters from the subroutine back into the JSR instruction that starts off. We'll show you how you can add. By default, it comes with 2 pairs. It comes with an input pair, and it comes up with a return pair that we can pass between subroutines. This is very seldom used, so we're not going to really teach that. We'll show you all the demonstration, and you know it'll be available if you need to do that. The SBR and return instructions should be used without parameters so the routine can easily be identified as subject. Jump subroutine, output instruction is unconditional, no input instruction between L1 and the JSR output instruction. A conditional will have one or more input instructions between L1 and the JSR. We okay so far? Yeah, we got it. It's in fact, I got an example in the book. It's just that, in RS Logic 500, we use a U file for subroutine. So we have U0, U1, U:0, U:1. Here all we do is we just give the subroutine a name. We'll show you how to set up a subroutine. So the SBR input instruction that is always true. If used, it requires an output instruction. We usually use a no-op instruction. This is not available. Every programming language that I've ever programmed in has a no-operation instruction. Used to when we programmed in BASIC, you'd start. You gave it a line number. You'd come in here. You'd say 1, 2, 3, 4, 5, and then you came in and you needed to insert a line. Well, you couldn't because why? You put them 1, 2, 3, 4, 5. So what you would do is you'd go in and put a few no-ops in between the line numbers, so you could do what? You can insert numbers. They do nothing. They're no-op, no operation. Eventually, when basic advanced, it would automatically put tens. It would go 10, 20, 30, and it would leave you space to put 9 additional rungs or statements in there. And you could always insert some inside there. But yeah, when we first started with basic programming, we learned a lot. But you could use a memory. You could use a memory bit, but if you use a memory bit, you're wasting a bit of memory. If you use a no-op, it don't waste any memory at all. If used, requires an output instruction, usually a no operation. Large Log 500 requires the data is needed to be passed from the calling routine into subroutine. If you use an SBR instruction. It's recommended because it automatically, when you go in there, you see that SBR is the first instruction, you know it's a log. You know it's a subroutine. Return RS Logic 500, this is before the end instruction, RS Logic 5000. It's optional, but we usually use it because it helps you identify the subroutine. But we can use it to pass information from the subroutine into the calling subroutine. So this is right out of the book, by the way. So here, this is seldom used, and we'll not be discussing further besides here. So what they're doing is we have 2 values from our main program that we want to pass into the subroutine. So we give the tag of the value 1 to value 2. Goes into the subroutine. They assign it to value A and value B. So here you have to give it a different tag, right? Does that make sense? Now, this subroutine can use those values. Even though it's in a different program, it can use those values. And by the way, by default, you get 1, you can add it to if you want to. I'll show you how to do that. What do you mean? No, there's no enable to none on the JSR instruction. Okay. Yeah, you'd see them on the left-hand side. So when it hits this JSR instruction, it's gone. Let's go over to the subroutine. Scans the subroutine 1 time, comes back to the original program. Brings its parameters back. So if you need to bring parameters, data back from the subroutine into your call-in program, then you would include that in parameter pairs inside here. And then what you would do is when you came back into your subroutine, this one would be the first one that's there, and it would be assigned to this in your actual main program. And you can add some more, return pairs here, you can add more return pairs here. I'll show you how to do this. I'll show you how to remove them. So basically, when we look at the JSR instruction, it's just going to be this, then, or something. So if we use a JSR instruction, you'll just see JSR and then you'll see the name of the subroutine. So you're only going to use those pairs if you need to pass data between what? The subroutine, which is technically another program. So if you do an add instruction up here, and then you use a tag, and then you get into this one, you can't access that data in the subroutine unless you do what? Unless you pass it. And then the return allows us to pass information from the subroutine back into the call-in program. I'm not going to call it the main program, even though that's what we're going to deal with. Because we could have a subroutine call in a what? Call in another subroutine. We call that nested subroutine. So this came right out of the manual. So your input pairs can be Boolean, they could be cents, int, they could be real numbers, or they could be structured information. We need to take a look at that. Return pair, they could be all this. Input pair could be all this. And then return pair could be all these different numbers or data types. So to create a subroutine, so here's my program. So it's already got a subroutine in there, but we'll go ahead and do it somewhere. To create a subroutine, I'm just going to come up here to the main program, and I'm going to say add, and I'm going to add a, see how easy that is? I'm going to come here and say what? Click on the main program, right click, choose what? Add, click on that, and give it a name. Okay. Here's where you can change programming languages. Unfortunately, we don't have a time to teach all these languages. Your main program is going to be Latin. All your subroutines, you decide what program you want to write it in. So technically, if you wanted to write everything in your in function block in your main subroutine, you'd put jump to a subroutine. That subroutine would be written in function block. So here's all our languages, guys. We can set this thing up so we can do it in sequential function chart, function block diagram, or structured text. That's the three. That's the languages that they support. So by default, it's going to give you what? Ladder. This says where I'm going to place that at. So here we're going to place it in the main program. And I'm going to come up here and say, okay. So notice it added a subroutine 3. Then I'm going to come up here and double click on the subroutine 3. And there it is. It's just like the main loop where we can start doing now. Doing what? Putting instructions. So these are all in the program control section. I think I'm past it. And here's our SBR instruction. Notice when I insert it, automatically goes on the left, right? Understand that? So it's got an input pair. So I can come up here and right click on this, and I can do what? I can add more input parameters, or I can do what? I can remove it. Now all you got is just an SBR instruction. So if you're not going to use those parameters, which we're not in this class, you're just going to remove those, right? You understand? And then I got to put, if I've got an input instruction, I've got to have a what? Output. So we'll come up here, and I think it's in program control, and I put a note, and that's the no op. You don't have to give it a tag. You don't have to give it anything, right? You understand? Is it in the program control book? Yeah, there it is. But remember, if you know what you're going to put in a rung, you know these little mnemonics, you can do what? You can just type them in, just put a space between them. And you can put them all in a string and then bring your branches in and pull them down into the branches when you need them. Right? So, that's the SBR. And then what should I put as my last instruction? A return. Am I still in program? Yeah, there it is. What's it do? course, they're being good sense. By the way, if you type them in like that, it don't put the parameters in there. If you go in and drag them down, you got to do what? You got to remove those parameters. Everybody okay? How to remove them? You just do what? Just right click. You can either add more parameters or remove the parameters. So that would be the start of our subroutine. So we're going to do this now. Now, when I come into this program, I know it's a law. I know it's a subroutine. Are we okay? Makes sense? Oops, wrong here. I keep forgetting. By the way, if you want to get rid of the subroutine, what would you do? I think you can just right click on it and you should be able to delete it. Okay. So here's our two subroutines. They're both conditional. And how do we know they're conditional? I got an input instruction on the left-hand side. This could be anything. It could be compares. It could be any type of input instruction that's available to you. Oh, I know. I was editing online, by the way. It lets you get by with some things. I shouldn't do that. Okay, so I think we're in run mode. So here's my first subroutine. So let's go into main routine. And here's subroutine 1. So it's going to move FFFF into my output. I don't have my camera. If I turn this around, you can see this. And then my second subroutine, when I run it, it's going to move zeros into the output. So we're running, so let's come up here and, which switch am I using? Oops, sorry. Okay, so I'm using switch 0, so I'm going to flip switch 0. Something's not working now. Subroutine 1. Oh, I know what I'm going to show you what's going on. So I'm using switch 3. So, make sure this is subroutine 2. I'm going to show you the problem we have, what you got to take care of it. So now I'm going to run the subroutine. So this would be switch 0. All my outputs turned on. You see that? Can't hold it up. I don't have my camera over here. So all the outputs turned on. So I'm putting. You can select the whole output by as soon as you go to or the whole output or the whole input instead of no, I'm not using a tag. But when you select the output, just hit enter when you get the data. Don't hit the little scroll button and go down and select 0, 1, 2, 3, 4, 5 and select the individual bits. If you do that, you grab the whole 16-bit or the 16-bit output. I'm not using a tag, so that's why I don't have it in my tag table. And then subroutine 2 should turn them off. Now this is the problem. So they're all on, right? You understand that? So what we're going to have to understand is that if you disable the subroutine, and you don't take care of your output before you come out of the subroutine, I'm going to show you that really in a minute, then all those outputs are going to stay on because it's not doing what? It's not scanning the subroutine. So the next subroutine should turn them all off. So this one turns them all on, this turns them all off. I don't know what happens if I do both of them at the same time. It's blinking. So we could actually look at the scanner. So I'm running two subroutines. One of them turns all the outputs on, one of them turns all the outputs off, and it's blinking. That's good. I hate to do that with a relay on it.
Quick to understand it. You run the main routine, take here, energize input, one,
Okay, let me bring the main routine back up.
input zero automatically jumps to subroutine one and executes on the action in subroutine one. You see what a subroutine one for? So it automatically energizes that input two there.
No, it's an input. I have to energize that.
Okay, so what is, if it goes to the source, okay, so
I don't know what you're asking.
So when you energize input zero in the main routine, you take the simple next step that it actually does from that point. You know it jumps to subroutine one. What does it do once you get to subroutine one?
It moves FFFFF into output by output word 1, 0,
So
dash.
what's the destination part of that move?
Yeah, that's just the move instruction. So move takes the information you come up here. I'm using a constant. I'm using immediate addresses, and it takes that and moves it into your destination. My destination, I'm specifying as I'm not specifying a bit. So my destination, let me go. So here's the actual program on the PowerPoint. So my destination, I'm specifying. So my destination, I'm specifying a local colon 1 colon 0 dot data. But I'm not specifying dot 0 dot 1 dot 2 dot 3. So if you do this, it takes for granted that you're updating the whole 16 bit or whatever you got available. So you can use this for inputs too. So you could I could input all those 16 inputs. Y'all only got 8, but I have 16 wired up on mine. So I could input all my inputs by doing what? So instead of when you get to data, you go ahead and you hit enter. You don't hit the little scroll button to go down and choose a bit. If you don't choose a bit, then you get the whole input port, right? You understand that? If you choose a bit, you only get one bit.
So just understand, the one, or you got energized input zero, it takes you to the destination. If you're required to energize two.
Well, the move instruction, yeah. So the move instruction is my source is 16 hashtag F. This is subroutine 1. Okay. And my destination, I'm putting this into local colon 1 dot 0 dot data.
That is coming from input zero?
No, my input 0 is controlling the subroutine. So if I turn that switch off, then it wouldn't move FFFF. It wouldn't move FFF into there. What I'm trying to, I'm demonstrating a very simple subroutine, right? You understand that? Does that make sense? So all I'm doing is just putting another control into the move instruction. That's all I do. That makes sense? Yeah, all I'm doing, so all I did was put another control into that. I could have left that out, but if I left it out and then I call subroutine 2, then what's going to happen is my lights are going to do weird things, right? You understand? So now I have the ability to turn off that move and turn on another one if I do energize both subroutines at the same time.
So input two is only just if you wanted to cut off.
If I just wanted to cut it off. Yeah.
Gotcha. So
And input three is just in case I wanted to cut it off. But you got to remember, these subroutines are going to be pretty. They can be pretty complex. So I don't know what's going on there. So this is the main loop. Normally we have a main program. So this is the actual. This is the RSLogic 500 program that's running the testing station, which is the second station over there. And then we come up, first thing we have is a JSR, but it's an unconditional, right? Now what we do on 500 is we assign it a file number. We call it U4. Here I'm going to do what? I'm going to give it a name. So that's the big difference. So RSLogic 500, it's always something colon something to identify where you're going to do it. So RS500, I would give every one of my subroutines. I wouldn't give them a name. I would give them a number, right? You understand? So like U0, U:0, U:1, U:2. We would give it that. And then on the tab, what we would do when it pops up on the tab, when we bring it up, we would give it a name. So this is conditional. This is something that we're going to talk about before long. This is first scan. This is used very often. This bit goes true when you first turn on your PLC and when you switch it to run. It executes this thing one time. So this is what they're doing is they're setting all the inputs. So if you go over there on the RSLogic 500 and when you turn it on, everything's going to go back to its initial position. And then, so this is conditional. This guy right here is unconditional, which means what? It means it's going to run every time we do that. It's going to go out there and run whatever programs in U6. This one's conditional. Then we do a little logic. We do a little logic. We do a little logic. And then we come down here and the last instruction is another jump subroutine. And that's your main program. So your main program is what? Real short. Because all it's doing is mainly doing what? Calling subroutines. And now we can split it up. So we got emergency stop subroutine. So if I was having problems with my e-stop, I wouldn't have to go through a big program. I could go right there. It's got a stop. It's got a reset routine. When you hit reset on there, it goes back and does a certain thing. So some of them are conditional, some of them are unconditional. So if you went into the robot, they're all unconditional. If you looked at the main routine on that robot, jump subroutine, jump subroutine, jump subroutine, jump through subroutine, pick up block, jump subroutine. So the main program is nothing but a bunch of subroutines. But what they've done is they've assigned each act that robot does, like pick up a spring, so it's a subroutine. So if I have problems with it missing the spring, then I don't have to find that section in my main program. What can I do? I just look at the subroutine and I sit there and now I can readjust my points and everything on the robot if you've had any programming without trying to find it inside a big old program that's 400 lines long, right? You understand? What do you mean? I'm listening.
I know we were going through that program, but I actually is it supposed to run the stuff?
Oh, you mean this program, the RSLogic 500 program? This one?
Well, the one that we were doing in RS 5000.
Okay.
Yeah, so it has to return back to the main. It goes through all the stuff.
Scans it once, goes back to the main routine. But what we've got is we've only got two subroutines. So the main program is a continuous program. So it's just doing what? So that means if I have that switch closed, every time it comes through, it's going to run the subroutine, come back every time, and that's what your main loop does. So your main program is what we call a continuous task. Later on, we'll look at what we call non-continuous tasks, which means they don't do what? They don't run all the time. We'll look at event-driven tasks where we can make them only run when an event occurs. So this would be, of course, this is an OR. This is an OR right here. So if this switch right here, if this examine if open, if it's true, it'll run the subroutine, but it'll also run that subroutine for first scan, which automatically sets up your line when you turn that thing on. So you're not going to come up and be, so if you got this guy over here and you got this guy over here, you just go ahead and say, if first run, we want to put everything back to its initial position, no matter where it's at. And that's what that subroutine up there does. But it's U5, it's U4. So on RS Logic 500, we just set up a U file, right? You understand that? We right click on the main program and it comes up here and say insert, and then we put U, and then choose 0, 1, 2, 3. We could have up to 256 subroutines inside that program. This guy here, I don't know. I know we can have 45 nested subroutines within a main loop. So we can have this one, call this one, call this one, call this one, call this one, up to 45 out there. So that would be, so it's just like me, when I'm coming up here typing on my keyboard, how many times do I type on my keyboard? Well, I type on my keyboard all the time. Well, what we do is we can call that from any section. So, if I run spell check, if I run this, or I run that, or I run this, and you use your keyboard, it don't type that driver into every program. It just calls it as a what? Calls it as a subroutine. So basically, that's all your operating system is, just thousands of drivers. Your application applies the drivers to something. So applications don't have drivers in them. But if they need them, they just go out there and call that what? Just call that subroutine. And they can call them as many times as they want to. So I'd hate to see the size of Windows 10 of that program, but it would be a lot longer if every application had to bring in their own keyboard program, right? You understand? But they don't. They just know how to call these drivers or these subroutines to cause the keyboards to work. So yeah, just about all your large programs are splitting up into modules, which makes it easier to what? Makes it easier to understand, because you can give the module a name. So I can come up here and right click on subroutine 1, and I can look at properties. You can give it a name when you create it, but we can give this a name of what it actually does, right? So if we look at the robot, the subroutine is given a name of what it actually does. So if I want to go to that subroutine, I just go down here and find it, see what it's called, and then the subroutines are listed down there. I just go into the subroutine and play around with it. If you want it to, if you're trying to get bugs out of it, and all you want is that subroutine to run and run and run and run, all you need to do is just put a jump and just jump it back up to the top. And once you get in there, it's going to just keep looping until you do what? So you get it right, So that's another option that you have. On the RS Logic 500, you just remove the return instruction, and it would just loop through there. So it's pretty interesting. So you can rename the main routine. So if you're running on an application that's running a section of your line, you can go to main routine and go to properties. And you can give the main routine. You can give your main program any name you want to. Just right there. Just right click and do what? Now you can give it a name which would match what section, of the line you're running. So all these things do that. We'll look at other things that go along. So this is a real simple program. And like I said, all this is in there is for control. Just another option. But the inputs are still scanned, so you'll notice even though the subroutine is not running, the inputs are still scanned, so the inputs are scanned first. But it's not updating the what? It don't update the outputs unless the subroutine. So any more questions? This is a good question here. It's real easy to create, so you don't have to worry about U numbers, and then you give the subroutine a name, and then you use the JSR instruction, and just over here put the name of your subroutine. Inside your subroutine, you treat it just like another program. What we want to do is we don't want to haphazardly split a big program up. We want to take sections of the program that's responsible for something, right, and then put that in a subroutine. And then we can give it a name.
If you were troubleshooting and you didn't have any subroutines in it yet, would you just add a line and throw in a subroutine and then close it off at the So how would you do that?
What do you mean?
Like if you were troubleshooting a program, but it was just, say, 15 lines, just straight programming, it wasn't broken in any section of it. How would you just throw it up?
Well, what you would do is, we've got the jump instruction available, and if you're having problems with a section, then you could jump backwards, right, and you'll just keep doing what? It'll just keep working until you figure out what's going on. So that's always available to you in a big program. But even in a 50-line program, you'd probably split that up too.
So you can just throw it, just add a line of those, jump.
Just go jump and jump it back. So jump it back up here, and then it'll keep doing what? It'll just keep scanning that until you take it out. And you could put some inputs in there, so you could flip it off and flip it on, and let it continue on. So you can make your jumps conditional. Sure could. Your labels, you don't have to make them conditional, but you can make your jump conditional. So you can put an input in the jump, turn it off, let it scan the whole program. When you want to say, okay, flip it back, and then it'll jump back and run that until you turn the switch back off. And so that's one way you could troubleshoot a section of the program. So good point. Any more? I think this is the, I'm not going to save this because I played around with it. So I think this is the one that's in the textbook. Okay, so nothing happens now, right? So I'm going to come up here and hit my start button, which is 0. Okay. Oh, I don't have a stop button. Stop button, I'm going to close it. Okay, seals itself in. Counter's ready to go. Okay. And then, of course, we see, go into my subroutine. Yeah, let me flip it up. Let me get it set up right now. This is the way it's written in the book. And then output 0 and 1 turns on. So they go like this. Can y'all see that? Okay, so I'm gonna come up here and give it another count. So what's my count into? 2. So this output is true. I'm gonna give it a count. Go back to my main program. So I'm gonna give it a count of oh, I lost my line program. Keep getting the switches confused. Okay. So this is a count of might have to zoom out. Oh, we can see our count right here. There's a count of 1, count of 2, count of 3, count of 4. Well, what do you know? It's still less than 10. Now it's greater than 10. I don't know what's going on with my first one. It don't look like it's updated to equal. Okay, but why? So that's exactly what we're supposed to see here. Why? Well, the subroutine's not running anymore. The outputs are not being updated. If the outputs are not being updated, they maintain their last position. So what I'm saying is when you do subroutines, you better take care of your outputs before you do what? Before you leave the subroutine. Because if you don't, if they were on when you ran it, they're going to be on forever if you don't run it again, right? Well, I'm using switches. So that's what I put my switches in there for. So what you would do is you would say, okay, what am I going to do? When I run subroutine 1, what am I going to do? Am I going to turn on outputs? Do I need the outputs on? Or do I need the outputs off when I leave, right? You understand? Or make a decision.
I think you just creatively come up with it.
Yeah, well, that's something you're going to have to figure out because your outputs are going to maintain their state because they're not being scanned anymore. So where there's nothing to turn, once they're on, if you don't turn them off, they're going to do what? They're going to stay on. That's fact. So what I did is I came in here and I put switches in all this. So once they came on, I would turn them off. And then I would hit some more counts. And once we saw it happen, I would do what? I would turn them off and then do this. So that's all we got to do. It doesn't mean you don't want to leave them on. You might want to leave them on until it runs the subroutine again. You might want to do that, you know. It's just like if it's unconditional, you got no problem because if it's unconditional, it's going to do what? It's going to scan it every time in the main loop. If it is conditional though, if it's a conditional subroutine, and you want output to be off when you leave the subroutine, then you better do what? You better turn it off, or it won't run until it happens again. But it might be the situation. So you might say, we got a counter, you know, and we can we can say if it's equal to this, we can use a limit and say if it's between this, right? You understand that?
I think the main, I completely with it, program, if I wrote the program with attention, I wanted to motivate and how like less, no longer less. So ideally, I wouldn't want it to stay on. So I guess they just have to come up with a creative figure out how to resolve it.
Yeah, you'd have to come up with a creative way to do that. So somehow you would run the subroutine again. You'd say, okay, if it's greater, then run the subroutine again, and maybe turn on an output, and then that output kills it, right? So you'd have to be creative. You can run these subroutines anywhere you want to. So you could run it here, and you could run it again in the next line.
Put maybe like another branch in that main routine. Look at the main routine. Put another branch at the bottom. When I just work at
Yeah, but we could say, okay, what are we going to do if it's less than? And then we could say, okay, what are we going to do if it's greater? And then if it's greater than, we could do what? Yeah. Yeah, so we could bring we could bring a branch and I'm online. We could, and then do what? Tell it to cut it off, yeah. Yeah. So I put, as just a little stopgap, I put switches in there. So what I would do is I would let y'all see it turn on, and before I went one more count, I would turn it off. So, a good point. So that's all I'm saying, guys. If you call a subroutine and you turn an output on, and you don't call it again and take care of that, it's going to be what? It'll stay on. But you can see on this program right here. So this is the big one. It bothers me that they didn't split this up further. So this one we got no problem with, because it's going to run every time it does what? The scan. So it'll update the next scan. This guy right here is conditional though. It's looking at a push button on the front of the panel. This has got no, this is the stop button. So if we come up here and look at the stop routine, which is U5, so we don't need to do anything. All they're going to do is put the outputs into a certain state when you hit the stop button. So this is ladder 3. This is still ladder 3. Still ladder 3. This is ladder 4. This is ladder 5. So they're going to latch, they're going to unlatch, let's see, and then down here they're going to fill a B3 file, but I don't know what they're exactly doing. But what we're doing is that we got no problem with something like this, right? You understand? So here it looks like they latch the output, and then they turn around and they unlatch it. No, this is A, they unlatch it. So what they're doing is they're dealing with an output, they're taking care of outputs when they hit the water button on the front, when they hit the stop button. Yeah. I think this is E-stop right here. It went all the way back to the front. Oh, duh. Now why they did, so this is E blank. So, they just fill the output with 128. So they're going to turn one output on and they're going to turn the rest of them off. Every time you hit the E-stop. Which it don't have an E-stop on that train. So could you imagine a program like this if you didn't break it up into individual subroutines? So what it does, it gives us the ability to take a real long program and make it into something more manageable, right? Like adding shells. So you put everything and stack it on top of each other. You can still get to it, right? Well, what happens when you want to get to this one? Well, when you take something and split it up into shells, now it makes it more manageable, right? So the subroutines you're going to write are very, very simple. We just don't have time to write very complex subroutines. I don't know if y'all going to do this one or not. I can't remember what's in the lab here. But it's just, I think they're going to do two subroutines. All you need to do is just do what? Come up here, right click on it and choose I need to go offline. So what's the first thing you're going to do? You're going to right click on the routine name, right? And do what? New routine and give it a name. And we're going to do ladder. And then that's all there is to it. If you pull it over, then all we're going to do is right click on this and say, do what? As soon as it lets me. Where am I at? I got it in my reset. Then we'll right click on this and say remove instruction parameters, remove instruction parameters. And then you get rid of those, and now all you got is the subroutine's name, right? Are they okay? How do you create a subroutine? Main routine, right click main, right click on the main routine. I'm sorry, right click on the main program and choose what? Add a new routine. So that's how simple it is. Very simple, right? And then give it a what? Give it a name. And if you don't want to delete them, You can just come over here and double click, type in JSR, hit enter, and the subroutine that it puts in there doesn't have a lot. It don't have all those parameters. So you'll still have to give it a name. To give it a name though, you gotta create it first. So I kinda got backwards a while ago. So you need to create the subroutine before you give it a name here, right? Everybody okay? Subroutines are real neat. I don't know what PowerPoint's doing.